Dodge Viper is an icon of American motorsport. It packs a powerful engine, raw, well-engineered handling, and most importantly, a stunning design. Look at those signature twin stripes. They have become a symbol of Dodge performance. Today, we'll take a deeper look at the Dodge Viper SR2. We'll explain why the SR2 has a drag coefficient of 0.36 and how we can upgrade it so it will become more stable and generate more downforce. Sounds interesting? Let's dive into it. As usual, air slows down at the front. That is where pressure is highest, and that is why designers pack cooling devices into this area. Viper is not exception. Notice the high-speed region just below the front bumper. The splitter squeezes the air, accelerating it and creating a low-pressure zone. Next, we have quite interesting aero tool, NACA duct. Here, its main purpose is to suck flow and direct it into cooling sections of the car. NACA ducts are very efficient since they almost do not create additional drag and at the same help direct even more air towards engine. Right after the NACA duct, we hit our first major problem. Look at the windshield, there's a major flow separation. It is due to sharp windshield which blocks a monumental amount of upcoming air that causes the airflow to separate. That is why most modern cars has really small angle and smoother hood windshield transitions. Next up, the roof, another common trouble spot. The airflow speeds up over the roof and forms a low pressure region. Less steep windshield angle would reduce that lift over the roof. Further back, there's a small gurney flap. It adds a bit of downforce and helps in terms of stability. However, it's limited by flow separation. The air isn't energetic enough to stay attached. Without enough kinetic energy, the flow detaches from the surface, reducing rear downforce effectiveness. Now, let's look at the underbody, the floor. The underbody is critical. We have seen that in our cars, that a smooth floor makes a big difference. However, most of the time we cannot physically install everywhere smooth panels, due to crucial car parts like engine, gearbox, drive shaft or exhaust pipes. In the Viper SR2, airflow doesn't stay attached across the underbody. Smooth panels have higher friction, while areas over mechanical parts show separation and lower effective friction. I also tested a fully flat floor. The airflow stayed attached much better across the whole underbody, increasing downforce, which shows how important a smooth floor is. Finally, the wake behind the car is massive, a sign of lost energy and aerodynamic inefficiency. This model achieves a drag coefficient of 0.36 and lift coefficient of -0.03. For a car with that much power, that level of downforce isn't enough to unlock its full potential. So now we have identified the Viper's key aero problems. Let's think for a while what upgrades could increase its performance. First, a longer front splitter will extend the lower pressure zone at the nose. We also need to energize the flow so it stays attached over the hood and toward the rear. Finally, a large rear diffuser should help manage the wake at the rear. Thanks to our friend Qvist, who helped with all modeling aspects, we managed to make an ultimate aero package for Dodge Viper SR2, which monumentally enhances downforce. Here's what we have changed. The package includes a longer splitter, a fully flat floor, an aggressive diffuser and new hood inlets. In the flow visual, the front airflow accelerates significantly, producing a stronger low pressure zone and more front grip. The new hood inlets create a local low pressure that pulls more air and energizes the boundary layer, helping the flow stay attached. Moreover, take a look at the rear. The energized flow from the front stays attached longer, reducing separation. That gives a cleaner flow which increases rear downforce. The flat floor eliminates underbody separation. The airflow remains attached and produces consistent downforce along the whole chassis. The aggressive diffuser accelerates the underbody flow and directs it upward, diminishing the wake behind the car. In this case, we achieved a negative lift coefficient of -0.53 and drag coefficient of 0.41. The results showed to us that upgrades were highly successful. In short, a longer splitter, flat flow, bigger diffuser and new hood inlets combined produced a huge downforce gain, with quite little increase in drag, proving to us that some aero adjustments can make a huge impact. For a Viper, that extra downforce is crucial. It helps the car put down that enormous power more effectively and efficiently. And if you would like to test your vehicle and upgrade it, then head to OS Aero Lab. There you can write a special request for us describing all aspects of your project. There's no doubt that Dodge Viper SR2 is an icon of American motorsport. Its design has already become recognized all around the globe. However, as this video proves, each car can be upgraded. Some aero adjustments may lead to huge increase in performance. Let me know in the comments which car should I test next time. Thanks for watching and see you in the next aero analysis.